Good afternoon, or yes, good afternoon, good morning for those of you joining us from the West Coast. My name is Andrea Johnson. I'm from Mohawk Medic, and it is my pleasure to serve as your moderator for today's session. I would like to welcome Alex Pavlushkin from Beta Software, who will be joining us to share his thoughts on machine learning and FHIR. So I will hand it over to you, Alex, and I will join everyone for the Q&A. As a reminder, your Q&A button is located in the center of the screen, and if you'd like to enable captions for this session, you can just press the CC button right beside it. Thank you, everyone, and over to you, Alex.
Thank you, Andrea. Hello, everyone. My name is Alex, and today I would like to share our experience of building, of packaging and building applications of machine learning using FHIR-First approach. For more than the last 3 years, I'm developing applications, medical applications on top of FHIR, and recently we have a couple of projects that were related to integrated medical applications in EHR system in hospitals, and we faced different challenges. I would like to share our experience, how we overcome it, and what solutions we developed. First of all, let me describe what is FHIR-First approach. FHIR-First approach is when we not only use FHIR for changing data between different applications, but we actually use FHIR for storing data in this format. We use FHIR server as a main backend for the applications, and use FHIR-REST API as a primary API. So this FHIR server can be extended with third-party applications and implement some custom logic. As a FHIR server, we use 8box. It's a great solution that provides out of the box a lot of useful features to build medical applications like user management, access policy, and many other useful features that can help us build medical applications very fast. So what I'm going to talk about, let's discuss data flow, application architecture, and some recommendations how we tested this application to be aligned with FDA requirements. To be more specific, I would like to bring an example of the case, the application we did with Prognosis. It's an Immunix platform, and this application, the goal of this application is calculation risk for patients that are in emergency department using 24 laboratory and flow sheet parameters that we get from EHR. Results as a dashboard are delivered via smart on FHIR specification. And once this application is built, it can be easily customizable for each hospital site, regardless what type of EHR hospital uses. Okay, let's start from data flow. We have first step, it's patient discovery. We need to get a subset of patients we would like to calculate risk for. We need to get all the data we need from EHR system to calculate the risk. Before we can save it, we need to transform and normalize, store it in a FHIR format, calculate a risk, use an ML model, and display results. Let's start with patient discovery. When we started exploring Epic FHIR API, we quickly realized that it's not possible to query observation and service requests without having patient ID and encounter ID. We need some context data for it. And it was not clear how to get these IDs using just FHIR API and request some resources. So we found out that several approaches how we can handle it. First of all, we can use CDS hooks. For example, encounter star hook can be run when patient admits to emergency department. And we are not going to show some suggestions as a response for this hook. We just capture patient ID and encounter ID that we can use for further queries. If CDS hooks is not available, HL7 v2 ADT feed is also a viable solution because we have patient ID and encounter ID, and we can use this information for further polling. Once we get access to hospital environment, we can start exploring resources because the structure and terminology may vary from hospital to hospital. And we used Jupyter Notebook to explore these resources. It's a very, very convenient way to make this analysis. It's a temporary solution, but it helps quickly understand with what data we, or access to what data we have, what is structure. Once we get patient and encounter IDs, we can fetch data. For the purpose of this application, we need three main resources. Patient, because we need to understand age of this patient to calculate risk. We need observations, obviously, and also we need information about some pending orders. It is because in some cases we need to, if we know that this observation is not available, but it's already ordered, we can wait some time for results to make calculation process more precise. But we cannot store raw data in FHIR server directly due to several reasons. First of all, we store all resources in FHIR-R4 format. And incoming data may be in different format. It may be in HL7v2. It may use other versions of FHIR. It may even use the same version of FHIR, but in some cases we need to change units of measure. In some cases we need to change type of observation. So how we can handle it? Let me bring a specific example. In HR system, there are two types of observations that describe a patient's consciousness level exist. First is Glasgow Coma Scale observation. The second is ABPU observation. Our ML service can consume only GCS observation. So we need mapping to convert one observation to another. How we can do it in a very flexible way without changing the source code? The answer is JUT mappings. It's an approach that we actually store the logic of converting one data structure to another in the document that part of our data. JUT mapping, JUT language has, it's open source. It has powerful functions to convert, to work with arrays, to do mathematical operations, and so on. And it's embedded in 8box. So what we need a proper mapping, we need raw observation, and using simple operation map and imply, we can get normalized observation. That's how it looks like. We have a raw resource, we have some script here, and we can see the result. Result is actually a transaction that can save one or several resources. We can implement conditional create or conditional update approach here. So it's a very flexible thing. The downside of this approach that data mappings are so important in the application logic, so we need to test it, and we need to test it for each hospital site. Now we can store our data in FHIR format. It's a pretty simple set of resources. It's like FHIR resources like patient, service request, observation, and encounter. The good side of this approach that we already have specification about data model. Actually, FHIR specification, it's a documentation for our database model. Yes, we can extend these resources if necessary, but generally FHIR covers all our needs. And now we are ready to calculate risk using ML model. Okay, we were given with a model written in R language, and we wrapped it using Python Flask framework and implemented just one endpoint that accepts normalized laboratory and flowsheet parameters and returns calculated risk and data about interpretation of this risk. The main advantage of this service is stateless. I had experience working with stateful ML services and stateless. And stateless much better because it's very easy to update. It's very easy to it's easier to test, and it's easy to scale. Another important thing that each request for risk calculation has duration about in average 40 seconds. So we don't calculate it once this dashboard is requested. We calculated the risk in advance in order to make this application working faster. And the final step is just smart launch and run this dashboard for the end user. Nothing, not very interesting at this step. Let's discuss application architecture. So we have external HR system and we have our applications. We split logic between two applications for one main reason. We would like to reduce the scope of this core application that calculates the risk and renders these results in a dashboard, because we would like to reduce scope of features we need to test, and we need to provide as feature for FDA approval. This application hospital, let's say it's a hospital connection application, implements custom logic to fetch resources from a specific system, and it works using FHIR API with the Monoscore application, populating all the necessary data. And if we have a close look to a Monoscore application, we have several components here. It's main FHIR server, Python application that actually implements logic to configure mappings I talked about, and it uses SDK to configure this FHIR server, and ML service communicates with FHIR service using REST API. And also we have a simple React application just to render the dashboard. And the last but not least, several recommendations that helped us to test this application without excessive effort. So it's not enough just to build this application. We need to get FDA approval. There are a lot of requirements, and we decided to use automation as much as we can. And we quickly realized that some tests can be run in isolated environment, but some tests make sense only against production environment. And for this purpose, we created several applications that test this logic. Examples. First thing is we have some high-level requirement that are converted to requirement for the application. And this requirement has a number. And we included this number, this requirement numbers in the unit and integration tests name. So it's very, very easy to understand if we cover all requirements. It's easy to generate automatic reports about it. Once we build images for our application, we run unit and integration tests. As a primary tool, we use PyTest and Jest, and as a result, we get some report. This report generates during CI process and is loaded to AWS bucket. So, and we use commit hash as a folder name to store this kind of reports. So it's a very transparent way how to store all these reports and be sure that we tested all we need. And we are not afraid to make some changes because we know that the vast majority of logic are covered with automatic tests. But some tests is not possible to run against in some isolated environments. So we created several applications to test this. Let's discuss runtime tests and some simulation tests. Here I would like to say that we have application that called client simulator that works as close as a real client. So it has some test data, and the test may last 8 and more hours. And here we can test not only that the application gives expected output, but it's a kind of load testing as well. During this client simulator run, we can generate screenshots because because dashboard view may differ, depends on set of observations provided, and depends on if it's pending or done. So it would be really tedious to test it manually, and this approach helped us a lot. And also we have a bunch of runtime tests. We test that application is accessible over using HTTP and not accessible over HTTP. HTTPS is available, HTTP is not. We also test backups, and not how backups are created, but actually we restore backup each time and check if it is okay. And also we generate some events like exceptions and errors and check if Elasticsearch and Sentry capturing this data properly. So we discussed what is FHIR-First approach and how we use it to build machine learning medical applications. We explored data flow, architecture, and approaches to test these applications. And thank you for your attention. I'm really glad to answer your questions. Thank you.
Thank you very much, Alex. So I see we have a few questions that have come in during the session, and I do encourage you to click on the Q&A in the middle of the screen and send them a bit more. First is a quick note from Isaac Vetter, who wanted to just clarify that while Epic does support CDS hooks in general, it is not supporting the encounter start hook. So it's currently not available in Epic, and he shares the public documentation for that Epic host, which I will share in the chat with our audience. Alex, do you have any quick thoughts that you want to reply to Isaac on that?
Yeah, it is, and that's why we use ADT fit as a primary way to get patient and encounter identifiers.
Great, wonderful, thank you. Another question is from Jackie Can. Who's initiating this workflow, the app user or any other data flow, i.e. messages?
Sorry, Andrea, could you repeat, please?
Sure. Who is initiating this workflow? The app user or any other data flow, i.e. messages?
Yeah, it's a good question. Actually, we have some silent part. It's like an infinite loop, and we periodically do patient discovery and fetch patient's data, but the end result, the dashboard is available when a physician clicks button and run this application over Smart on FHIR. But these results are pre-calculated on the previous steps.
Thank you for that. Any other questions from our audience? Give everyone a few minutes to type in. All right. So seeing none, Alex, what's the best way for everyone to reach you if they do have any questions after the session, or if they're watching this recording and you aren't here and they want to follow up with you?
Please use Telegram or email to reach me. I will be really glad to communicate, and also I will be available in FedLoop, I think, to chat. Yeah.
Great, wonderful, thank you. I'm glad you didn't say fax, because I think if there's anything we've learned at this conference, no more fax. Fax is in the area. All right, well, thank you everyone for joining us. Just a reminder, we are going to have a little bit of a networking rest break for everyone. So the next sessions at CodeCamp and FHIR Academy will begin at 3 p.m. Eastern Standard Time in your local time zone as well. So please feel free to connect, message each other. You can set up your own little networking groups in the networking tab on FeedLoop. And as a reminder, for those that are craving any in-person connection and are based in the Toronto area, we are hosting a networking event brought to you by Smile Digital Health tomorrow night, and registration is still open for that. So message your FHIR event host if you want the direct link for that. Thank you very much, Alex. It was a pleasure and we appreciate your time. Have a great day, everyone.
Pleasure for me. Thank you. Goodbye, Andrea. Goodbye, everyone.